All right, so let's look at these two problems here to get an idea of where we're going today. It says the graph below shows the distance feet from the rainforest floor over time, hours, as a sloth descends along a tree. What does the point 0, 25 represent? So that's this point right here. The x-axis is our time, and the y-axis is our distance. So what this point means, 0, 25, is that when the time is 0, that the sloth is 25 feet above the ground. So we can write that as the sloth starts 25 feet above the ground because no time has passed because the x value is 0 and the y value is 25. What does the point 4, 0 represent? Okay, 4, 0 is right here. So now the x value is 4, so that means 4 hours have passed, and the y value is 0, which means the distance above the ground the sloth is now 0. So this means after 4 hours, the sloth is on the ground. Now the next one says Mr. Flikowski was asked to graph this equation. How did he do? Well, remember we have y equals mx plus b, where this is your y-intercept, where you start. So we should be starting at -2. Okay, good. And this is our slope, which is the rise over run. So in this example, we should be going up 3, and right 2. So if we go up 3, 1, 2, 3, and right 2, nope, that is not correct. So the original line here that I graphed is wrong. The slope was used incorrectly. The slope was incorrect. Should be up 3, right 2, instead of up 2, right 3. And that's a very common mistake to make, getting the slopes mixed up. The top number is how far you go up or down, and the bottom number is how far you go left or right. Okay, let's look at this page for some examples. We're going to graph each of these systems and find the solution. The solution is going to be the intersection point. So let's graph the first one on the left here, -4x plus 5. So we're going to start at +5 because that's our y-intercept. Then -4 means we're going to go down 4, 1, 2, 3, 4, and right 1. You could also go up 4 and left 1. And that will be our line right here. 1, 2, 3, 4. Okay, and then the next one is 3x minus 9. So we're going to start at -9. We're going to go up 3, 1, 2, 3, and right 1. 2, 3. And the intersection point is right here, and that's our solution. It looks like 2, -3. So we have to write it as an ordered pair. It is important that when you graph these that you are precise, because if your lines are not straight, then your intersection point might be a little bit off, and you get the wrong. Let's look at this one on the right. So we have negative 3x plus 7, so 1, 2, 3, 4, 5, 6, 7, then negative 3, down 3, right 1. And it's important that you are taking your time with graphs, because if you don't, your intersection point might not be where it should be, and it's because your lines are not straight. All right, so we start at negative 3 and up 2, right 1. So this is what that line would look like. And the intersection point is right here. Looks like 2, 1. So the answer would be 2, 1. Always make sure to write your answer as an ordered pair. Now, it'd be nice if all of your equations were set up that way. Look at these, though. We don't have y by itself in any of them, so we need to get y by itself first. So on the left one, we're going to add 2 to both sides. Now we get y equals negative 1/3 x plus 2. And we can graph that one. So positive 2. Negative 1/3 means going down 1 and right 3. Now, in the second one, we've got to subtract 3x from both sides. So we get negative 3y equals negative 3x plus 6. Then we have to divide everything by negative 3. So this gives us y equals negative 3x divided by negative 3 is just 1x. You don't need to write the 1 in front. 6 divided by negative 3 is negative 2. Here, start at negative 2, and then we go up 1, right 1. Up 1, right 1. And our line looks like this. And our intersection point is right here at 3, 1. So that is our solution. So you need to work and get y by itself before you graph. Up here, y was already by itself, so we were good to go. Down here, both equations, you need to solve for y first. All right, so on this page, I'm going to have you work with your partner or a small group to graph these 4 sets. Just a heads up, when you get down here, you need to make sure that your y value is all by itself. Over here on the left, it's not, so you'd have to divide everything by 2 first, the left and right side. And over here, you have y plus 1/2 x on the left side, so you'd have to subtract 1/2 x from both sides first before you can graph that. So with those hints, I'm going to send you away to go graph these. All right, these are the answers here. And as you can see, the one on the left, you should have the 2 lines crossing at 2, 2, and they only cross once, so there's one solution. The upper right one, these 2 lines never touch or never cross, so there's no solutions because they never touch. The lower left, that one has many solutions because once you divided the left one by 2, they were the exact same line, meaning they would always touch. And then the lower right one, once you simplify the left expression to get y by itself, you would get that the lines cross at 2, 2, meaning there's only one solution. So how can you tell if there's going to be no solution, one solution, or many solutions, also known as infinitely many solutions? No solutions will give you parallel lines, and those equations will have the same slope, but different y-intercept. And when you graph them, the lines do not touch. That's how you know there's no solution. One solution, the two lines touch just one time, and the solution is an ordered pair, that is the intersection, written as x comma y. You need to write both coordinate, or both points. So you can tell if we have no solutions, one solution, or infinitely many solutions based on the graph. No solutions, the lines are parallel, which means they never touch. In the equation, they'll have the same slope, but different y-intercept. One solution, the two lines touch exactly one time, and the solution is the intersection point, written as an ordered pair. So it must be written x comma y, and your x and y values would be the coordinates of the intersection. Infinitely many solutions, that happens when you have the exact same line. So I hope this was a nice refresher from Algebra 1 when you guys talked about this, and that you just now have a better understanding of it, or a decent refresher of it, so that when we move on, you can remember what we talked about today. So make sure you like this video and subscribe.